Can you repeat?
Okay.
The question is, a house owner replaces a failed fuse for the lights of the house. When the lights are switched on, the second fuse also fails. The house owner then uses the third fuse with a higher rating than the previous two. Why is this not a sensible thing to do?
Yes, now understood. Yes, Aishwarya, understood.
Yes, understood.
Yeah. So basically, there is a fuse. First, do you all know what is fuse? Do you all know what is fuse? Yes or no?
Yes.
Yes, Ashwant? No?
Ma'am, I know.
Yeah, what is fuse?
Fuse means when an electricity got blasted is called as fuse. Just when I was touching the router, it got fused.
Okay. So suddenly the power will shut down. Something suddenly power gets shut down, like then people will say fuse has gone. Have you heard of this? Fuse gone. Yes?
Yes.
So what do you mean by fuse? This is actually in your book, they have not mentioned anything about fuse, but this is a higher order. So it means you should know. So there is something called fuse. So there is a circuit. There is a circuit. Let's take bulb. There is a circuit. So this circuit is capable of, not the circuit. Please listen everybody very carefully. This bulb is able to carry only 20 amperes of current. 20 amps of current. Okay. There is a circuit. There is a bulb in the circuit attached, and this bulb can only get 20 amperes of current. More than that 20 amperes it cannot hold. Okay. So we will attach a fuse here. Okay. We'll attach a fuse here. This is, just remember this as a fuse. So what is this work of fuse? Whenever there is an extra current flowing in the circuit, this fuse will stop it. This fuse will stop it, stop the current flowing in the circuit, and it will not allow the current, that extra current is going to the bulb. For example, this electric circuit is giving 25 amps. Okay, what the fuse will know, it will stop it. The fuse will stop, and when it comes here, the fuse will know that there is like bulb can hold only 20, but 25 is actually coming. So fuse will know. So fuse will stop it. Fuse will stop the current going further to the circuit and hit the bulb. So that, you know what will happen? Electricity will go. Complete full electricity will go. So that time what we will do? Electrician will come. They will change the fuse. They will change the fuse and they will replace with a new one. So the scenario is like one electrician is coming. Like this happened in a house. One electrician is coming. He's changing the fuse for one time. Second time also same thing happening. First time it happened and changed the fuse. Electric man changed the fuse. He went home. Again it same thing happened. The bulb like again fuse gone. Again he's coming. Again he's changing. So will there be any end to it? So you know third time what he is doing? Instead of changing the fuse, is increasing the capacity of the fuse. So 25 amps of current is coming. So this capacity of fuse is 20 amps. No, I mean capacity in the sense when it exceeds 20 amps, this fuse will not allow. So what the electrician is doing, it is increasing the capacity of fuse. So even if it is more than 20 also, it will allow now. No, he is basically increasing the capacity of fuse. Will that be a good idea?
No. No, ma'am.
Why?
No, ma'am. Because the bulb can only hold 20 amps.
Yes, exactly. So if you change the fuse, current will not go. Means current will come, but the bulb will blast. No, that is not a viable situation. That is not a viable decision to take. So that is actually Siddhant. That was actually Siddhant's doubt. So why it is not viable? Because the appliances itself cannot hold that much of current. So it is better to check, is there any leak in the circuit. It's better to go and check the full circuit, why there is extra current. Like that, we have to check where there is a leak. That is, yeah.
What is a resistor then?
Resistor. Yeah, very good question. There is only one difference between resistors and fuse. There is, this is a circuit. Everybody know what is a resistor?
while doing any science project, my teacher always says that use resistor in your circuit.
Yeah. Anybody know what is resistor?
Ma'am, I don't have any idea. I'm like hearing from the first time.
Okay.
Me too.
There is something called resistor. The work of the resistor is same as the fuse. Same as the fuse. Resistor is also going to resist the electricity, more electricity. Resistor, work of the resistor and fuse, both are same. So what is
Ma'am,
the
so
one
it's just a
difference?
different name.
Yeah. So there is only one difference. When you use fuse, actually what happens when there is extra current coming here, the fuse melts. Fuse will melt and it will cover the electric circuit so that the electric circuit will not get damaged. Do you understand? When there is an extra current coming into the circuit, the fuse will melt. It will melt. So fuse has that capacity of melting itself. When there is an extra current, it will melt. So I told now it will stop like that. How it will stop? It will melt itself on the circuit. So this is a circuit. This is a fuse. It will melt and it will be like a layer on the circuit. So that the current will not go as also and the circuit will also be safe. But when you use resistor, that case won't be happening. When you use resistor, resistor will also resist the overcurrent, but the circuit will damage. There is no function of melting and protecting the circuit. No, circuit will damage. This whole circuit will damage. You have to replace the circuit entirely. But when it comes to fuse, only if you want to plug that area alone, take the fuse off, put new fuse. That's all. But when it comes to resistor, you have to replace the entire circuit. That is why in home appliances, we use fuse. Always we use fuse. For laboratory appliances, for laboratory condition, we use resistors. Yes?
How does a resistor look?
What?
How does a resistor look, ma'am? Like
Resistor look. Okay. I'll show in net.
ma'am, because I think I have a resistor like in my home.
Resistor looks like I have seen the resistor in my lab. I'll be showing you.
Ma'am, can you give me
Where
a
is
minute? Like I'll get it.
who is talking? Siddhant?
No, ma'am. This should.
Okay. Yeah. So yes,
Yes, ma'am, I
resistor
have
will
it
look
in my
like
home.
this. We use this for electric circuits. If
Yes,
see,
ma'am.
this is a symbol. So this symbol I have drawn here. Can you see in the PPT? See this symbol I have drawn. No, that is the resistor. The symbol that you have to represent the resistor in circuits. When you're drawing circuits, you will represent like this. Okay. And now I'll show you how fuse looks.
Ma'am, my network connection was low when you explained resistor. Can you explain again?
Yeah. Can anyone Siddhant explain fuse? Sorry, resistors. What is the difference between fuse and the resistor? Did everyone get, first of all?
Mom, I have a doubt.
Aishwarya,
Ma'am,
Ashwant.
ma'am, I understood fuse. I can explain him what is fuse, but I got confused. Like, what is resistor? Like, I just wanted to ask, but you were showing, that's why I just kept quiet.
See, there is only one thing is there. Both are same. Both are meant for a purpose, but only one thing is there. Fuse is wherever you want to protect the circuit, you will use fuse there. Where there is protection of circuit is highly important. Why? Because when there is an extra current flowing in the circuit, so you all know that current have heating effect, right?
Yeah, ma'am.
So heating effect means it will burn. Basically, it
Yeah,
will
ma'am.
burn everything, right? If there is over current, it will burn. So if you increase the current in the circuit, so the circuit will get damaged, right? Obviously, circuit will get damaged because it cannot hold that much current. It will get damaged. But when you
Yes, ma'am.
use resistor, it will stop the current so that it will not reach the appliance, but the circuit will get damaged. Understood now? It will stop the current so that it won't reach the appliance, but the circuit here, this part is
No,
what will
not
get damaged.
that. I cannot see anything. My Zoom is stuck.
Ma'am, is this the resistor?
Resistor is here. So this is fuse actually, if you want to see. This is fuse. Fuse will be like
Ma'am,
this. Yeah.
ma'am, how does electricity pass through this thing?
No, they will be at. Have you seen this thing in your home? It will be there.
Yes, ma'am.
Yes, ma'am.
Yeah. So this because this will be actually used for fuse. This is actually fuse. And
Ma'am, that means that a resistor will block the current that is coming, like excess current,
yeah,
but that will not protect the circuit. And
exactly.
and the
Yes.
fuse will do both the things.
Stop.
It will protect the
Exactly.
circuit also, and it will block the current also.
Yes. Yes.
Ma'am,
Yes.
ma'am, can you explain the resistor again? I didn't understand.
See, Aishwarya, the function of resistor and fuse both are same. Same to same. There is no difference, but only one difference is there.
My mother
Fuse,
just told
yeah.
before that if so much electricity is passing through, the fuse will break and then no more electric current will flow.
Fuse will go. You will say fuse will go in local language. In electrical language, proper electrical language, you will say fuse will melt. Melt. It's actually melting. Okay. There is some. I also have not seen technically
Why
how
does
it melts
fuse
and
get
all.
melt?
Yeah, that's what I'm about to say. Because I'm not an electrical student, so even in my schools they have not conducted this experiment of melting the fuse. They have not shown me how it will melt in the the circuit, and I just know like it will melt. I know the differences and these things. I know technical stuffs, but I have not seen it practically. So it will be very
Sounds
good if
like
you see
a
practically.
sad idea.
If you see it practically, it will be very good. Actually, if I find any video, I'll share. Okay. So Aishwarya, basically fuse and resistors are same. Okay. If there is a just think there is a bulb here and there is a resistor in a circuit and there is current
Resistor in the
flowing.
circuit?
Resistor is placed in the circuit. So Sudarshan. Okay, so this is the resistor. So when there is an excessive current passing here, the resistor will stop. Resistor will stop. But it cannot protect the circuit because you know very well that when there is an excessive current, excessive heat will be there, right? Because heating effect is the part of current. So when there is excessive heat, obviously the circuit will burn off. Circuit will burn off, right? So it will actually, if this area will burn off. So you have to replace the entire circuit. But what is the meaning? Like, what is a fuse? That is what fuse means. If you replace the resistor with fuse will actually melt. Whenever immediately when there is it
The current will just break. It won't
yeah,
flow.
current will break through the circuit, and also it will very immediately, very fastly it will melt. So that when it protects the circuit, like it will be on
Also,
the
that thing
circuit,
in
it
the
will be like a
middle,
shield.
ma'am,
When it
also that
melt,
thing in the middle of the fuse.
Ma'am, does the resistor melt?
no, that is what I'm saying. Resistor will have the capacity to stop the flow, but it is not protecting the circuit.
Okay, ma'am.
Ma'am, if we
Yeah.
like keep full of resistors, then like in this circuit,
Like what I didn't get it.
like full of resistors in the place of wire, like that, giving connection small.
I am so sorry. I didn't get. Once again, can you come?
Ma'am,
He's
he's asking that.
can we replace resistors in place
Yeah.
of like wire?
Ma'am, like he's asking. Yeah, that's what.
No. I didn't get still now. Please, one more people say.
Ma'am, I think he's saying like it's like fuse protects the circuit, right? So he's asking in
Yeah.
every part of the wire. What if like we
Why
keep the resistor? I think he's asking
instead of
that.
fuse? Instead of fuse, what will happen if I keep resistor?
In every place.
Yeah?
Yeah, I think.
Yeah. Do you want to try that? You have to replace the
Yeah.
fuse and keep resistor everywhere. Then you have to always spend 50,000 whenever there is an excessive current, and especially in India, we don't get current in a correct manner. our voltage will drop every time, and high, dropping high, right? Every time in India we get this problem of voltage drop and voltage high. So whenever the voltage is high, full entire circuit will go off. Full circuit, like full circuit, entire building will go off. So you have to replace the entire stuff. The main part, at least somewhere, from the main area you have to replace. So it will cost more, right?
Ma'am,
It will cost you
okay,
more
ma'am.
amount. Yeah.
Ma'am, like if fuse melts, it will go all through the wire or only one place?
It will melt there only. So basically it won't allow to stop, and it will melt in the exact. So whenever the fuse is like, the main function of fuse is when it depicts, like when it what to say, like when it observes that excessive current is passing, that time itself it will melt, so that in future also it will not happen. That time also it won't happen. Like it is, prevention is better than cure kind of policy it will follow. But resistor is, when it is coming, it will stop at that particular time. So almost all the circuit will be burnt off. And the rest of the thing, like till here also, it will be burnt off. Understood? This is like more of electrical things. So if I get some YouTube video on like how this works, I'll show you. Yes, so that you will understand better. But basic function of fuse and basic difference between fuse and resistor is this. Fuse can melt and like they can help the circuit. They will be protecting the circuit. But when it comes to resistor, it won't. Right?
Mom, I have doubt.
Yeah?
Mom, I have doubt.
You're so low, Charvik. Your voice is so low.
I kept it in chat. Can you check it?
If anybody
Can you see
is,
my screen?
I no. Yeah, that is resistor actually.
Yes.
Yes. Understood, everybody at least got an idea what is a fuse and what is a resistor. No need to
Yes,
go
ma'am.
very deep. If you are going to take electrical engineering in future, you will learn everything. You will work on this. Yes.
Mom, can you see my screen? Can you see my chat?
Charvik,
I think is
What is the
kind
difference,
of-
like where we use resistor and where we use fuse?
yeah, that's what I was telling. In fuse, wherever we need high protection, where we need in our home, like in our day-to-day life we are living, no? So in our homes, everywhere fuse will be there.
Yes.
If you ask your parents, they'll be knowing. But when it comes to laboratory experiments, so when we are experimenting something in electricity under the laboratory situations, we don't really need the fuse, because it is all under our control, right? It's all under our control. So we really don't have to worry about like when it will come high, when it will come low. But still resistors are important for some calculations. And like if you are implementing that part in real life, then you can replace a resistor with fuse. So there is something called model, sample, and big thing, no? So before doing some big thing, we will build a model of that. We will check whether everything is working right or not. So that time we can use
built
resistor.
a model.
What?
Big thing built a model.
No, I'm saying, if you guys all know, right, there is something called model. Like if you, for example, you are going to build a house, they'll give you blueprint, they'll give you some small model house, no? Are you
Really?
all aware of that?
Yes, ma'am.
So I am talking about that only. So when there is a small model, so that time constructing the model just for experimenting sake,
Ma'am, your voice is
under
breaking.
laboratory condition. Is my voice breaking to everybody?
I'm like sometimes it's breaking.
No, ma'am.
Okay.
Was not breaking.
Ma'am, Chavik's doubt is that like why resistors are present in fuse?
No, it is not present, Charvik. Where did you see? Is it? I don't know. I have not seen like that. Yeah. Really? Okay. If that is so, I'll go to the books. I'll check multiple books and I'll come back. In the next class, I'll tell you if there is present like that or not. I also don't know. I don't have any idea. You saw in Google. Okay. I'll also see. I'll see if I got any diagrams, I'll come. Okay. Maybe it can be possible, I'm saying, because fuse is like resistors are there, right?
Ma'am,
So
but how do
they
you even
inspired.
ma'am, how do you even insert a resistor in the fuse?
Yeah, that day only I don't know. Actually, I don't know, right? So I don't know the mechanism of like construction of fuse. Basically, what is fuse and what is resistor, like we all know. But how the fuse looks like, what is the construction of fuse, those things we don't know. Actually, we don't know. Like if you want to go very deep into that, we'll have some videos. I'll see some videos in the YouTube. I'll show. Okay. I'll clear your doubt, Charvik. If it is so, I'll clear in the next class. Okay. So now I hope you understood both resistors and fuse. We have a
Ma'am?
formula also for that. Yeah.
Why will it melt, ma'am?
Yeah.
Ma'am,
To protect the circuit, it will melt.
because when so much electric passes through, then it will melt.
Because
When
of
there
the
is
heating effect of
heating
steam.
effect.
When the
Yeah.
electricity pass, it produces
Plastic
heat. So due to
plastic
that heat,
melts, right? Plastic melts if you put them in the fire, right? Charvika, Chakrika.
Okay, ma'am.
Like that, it also have heating effect, no? So because of heating effect, it will burn. Yes. So yes, coming to the next part, circuit diagram. Electric circuit, another circuit diagram, like basic electric circuit diagram. I hope you all know this. We all saw. So this is bulb. Basically, when the switch is on, the bulb is glowing. When the switch is off, the bulb is not glowing, right? So this is a basic circuit diagram. You must be knowing how to draw a circuit
Yes, ma'am.
diagram. So when I ask you to draw, you should make a simple circuit diagram like this at least, right?
Yes.
ma'am, we
You
have
can
it
put
in
a
our
resistor. Yeah, you have to make it a simple one. That's it. No need to go very deep. Now we are going to talk about one new thing, series and parallel circuits. So I already explained what are resistors, no? Resistors are electrical components that limit or regulate the flow of electric current in an electric circuit. They are fundamental components used in almost in all electronic devices. Yes, resistors, fuse. Fuses are now replaced. Yes. So now we are going to talk about series and parallel circuits. So what are series? So just you have to know what is series and what is parallel, how they look like. That's it. Series circuit is made up of connecting the end of one device to beginning of another device. Basically, the circuit starts from here. Two bulbs are connected and the circuit is ending here. There is no intervention here. Right? This is on off
Series current
switch.
is like you can say normal current.
What?
Like series current means you can select a normal circuit.
Normal circuit. There is a normal circuit. There is bulb 1, there is bulb 2, and there is battery, and that's it. The circuit is over. Switch will be there. So parallel circuits.
if
What are
one
parallel circuits? Yeah.
if one bulb will be there, then also it is series or it will
Series.
come. Okay.
Series. So whenever I am telling you, when there is an electric circuit is not divided anywhere into any part. Here, electric circuit starts from the plus, directly goes and ends in the minus. But here, see, it starts from the plus. It is dividing into two different parts, right? Yes, it is.
Which part will it go in first?
It will go parallelly. That's why it's called parallel. It goes at the same time it enters here, at the same time it enters here, same time it passes, right? And again it comes, joins and comes here, right? So when the circuit is starting, it is dividing, the circuit is getting divided into two different ways. We are adapting two different ways and two different bulbs are present, right? Into many parts, many ways. Some noise is coming. Yeah. So when there is a circuit is dividing into many parts, like see 1, 2. So I can also draw many circuits like it will be 1, 2, 3 also will be there for some circuit, and all the 3 will get joined here and then it will come as a single circuit. 3 is also possible, 4 is also possible, 5 is also possible. Yes. Yes.
like
Understood?
the bulb will not glow brightly, right? In that case.
No. Nothing like that. It will be equal.
Okay.
1 second, children. Yeah. Sorry. Yes. So did you understand how the series and pack like? Yes.
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 Yes or no?
Yes, ma'am.
Yes.
Ma'am, I have one doubt.
Nah. Yeah.
I'm in parallel circuit once
Yes.
the like
Somebody has doubt.
in ma'am me. Ma'am, in parallel circuit once it like
Yeah. Yeah.
it once the electric current is passed from this like the switch, then it has two bulbs, one in the top and one in the bottom. So generally if we keep one bulb, then it will pass the bulb
Yes.
and again the same electricity will come and it will be a cycle. But here will it be a
What if we keep
cycle?
only one bulb?
Sorry, ma'am. Ma'am,
Cycle
so
in the sense, until unless you switch off, it will be a cycle.
yeah, ma'am, that's what. So first it will
Yeah.
go like it will be separated or like it will be separated. So again in that two separate regions will it form like that? Like ma'am, in the two separate regions,
No.
will the electricity flow in that
Understood.
only?
Understood. Yes. You are asking, will there form any cycle?
Yeah, ma'am,
here?
in that part, yeah.
Correct? Absolutely. If you see, current will come till here. There, it's not like cycle of current, not cycle exactly, but yes, it is cycle, but it is not cycle also. See here how it is. It is current is coming here. Current, one part of the current will go this side, one part of the current will go this side. Bulb will
Yeah, ma'am.
utilize the current, and again it will pass through the circuit from here. Again it will pass through the circuit from here. Actually, it is like a cycle, but it will not go back. From here, again you won't have the current. From this part, again there will be no current. Only current will go this side. Current will not come the opposite side. So it won't be a cycle, obviously. Right?
Ma'am, just a minute. Like
Understanding?
I'll just try to open my camera and I'll try to ask my doubt in that. Just a
Okay.
Ma'am, like what is MCB?
Ma'am, serious
Yeah.
current means a serious current circuit is serious. What is serious circuit? A serious circuit is made by connecting the end of one device to the beginning of another.
Of another. And by the end of one device to the beginning of another. Right? So it is
Ma'am,
end
he's
of one
saying
device.
Google.
What?
He's looking at Google.
No, he's looking at the slide and saying. He just saw the slide and said. Yes.
Ma'am, can you see my camera?
Yeah, I can see your camera.
Ma'am, so once the like the electricity passing from here and going like this, so will it form a cycle in this areas or will it come again and like that same
No
cycle?
cycle.
Or will it,
No
Parallel
cycle.
circuits means
Ma'am,
Ma'am,
Siddhant is drawing something.
ma'am, so
Yes,
that
Siddhant.
means that from here the electricity here will be separated, here one will separated. Then once it complete the like the electricity pass to the bulb, it will
Yes.
directly go here. It will not form a cycle in here.
No. No cycle. It's
Okay.
not possible. Technically, it's not possible. Because the electric circuit is one way. One way. It's not two way. Two way. One way means buses going this side, some other vehicles will come this side. This is two way. But electric circuit is only one way. Always the current will pass through only this side. It will not come this side. So basically, when the current starts from here, there is a cycle here. If you see, whole cycle is there. But only here, if you ask, no cycle. Because
Okay,
current
that,
always enters from this side, from this side. Won't be vice
okay,
versa.
that,
It will always start from here and exit from here. Yes. Now got
okay,
it?
ma'am.
There will
Yeah,
be
ma'am.
no cycle. Yeah. So V is equal to, okay, fine. Before that, we will complete this Ohm's law and then we'll go back to there. Okay.
Ma'am,
So now you
parallel
guys all
cir-
understood what
parallel
is series and
circuit
what is
is
parallel. Yes.
in parallel circuits, the same terminal of both devices are connected together. Right?
Yeah. Yes. Yes. So what is Ohm's law? So now you guys, you all are aware about what is a
Now,
resistor.
Ohm's law. Ohm's law is a fundamental principle in electronics and electrical engineering that describes
what is
the
logo of Omega?
relationship between voltage, current, and resistance is an electric circuit. It states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the.
Okay. So that is Ohm's law actually. You're correct, Sudarshan. So
Ma'am.
Ohm's law is a fundamental, yeah?
Ma'am, why is that in the logo of Omega?
That is a symbol of Ohm's.
Ma'am, we can't hear you.
Symbol of
Provided the
Ohm's.
temperature remains constant formula.
That is ohms. We say it as ohms. So we have what is that? Current is measured in ampere. Like voltage we have, current in amperes we have. So the unit of resistance is ohms. You have to remember this. I forgot to say. Unit of resistance is ohm. So ohm resistance is basically calculated like unit is ohm. So instead of writing OHMS, you can write like this symbol. You can use symbol. Yeah.
Ma'am, in the circuit diagrams?
No. Not in the circuit diagram. Circuit diagram representation of resistance is this. Like this.
Oh, ma'am,
When,
it's like the resistor.
yeah, resistor. Yeah. But when, yeah, it is resistor. The resistor will have some value of resistance, right? Resistance. So
Yes.
resistance is calculated with the help of, like the unit of resistance is ohms.
Okay, ma'am.
And now coming to the very important part, Ohm's law. Very important. Ohm's law is a fundamental principle in electronics that describes the relationship between voltage, current, and resistance. So we know what is circuit, we know what is voltage, we know what is current, we know what is resistance, everything we know. Now the question is how they are all related to each other. So before we saw I is equal to Q by, I is equal to Q by T. So current is equal to charges by time. What is the relationship between current, charge, and the time? That is actually that. So I asked you, when I increase the current, time will go down. These are some discussions we had. Now, if there is voltage, current, and resistance in a circuit, there will be some voltage, there will be some current passing on, there will be resistance going on. So what is their relation? What is how they are related? How the voltage, current, and resistance are related to each other. That is what Ohm's law is stating. Okay, so it states that electric circuit, where is that? Yeah, electric current flowing through a conductor between 2 points is directly proportional to the voltage at across the 2 points, provided the temperature remains constant. So V is directly proportional to the current and V is directly proportional to the resistance. It means if I increase the volt, current will also get increased. If I increase the volts, current will resistance will also get increased. So V is equal to IR. This should be your fundamental principle till, like, if you take some electric subject also in future, this will be very, very basic formula. Around this formula only everything will be there. Okay, so the mathematical expressions of Ohm's law is V is equal to IR. Yes. V is equal to IR. Please note it down. Yes. Got it. Shall we
Yes,
go
ma'am.
for problems? Shall we go for problems?
Yes.
Everybody clear? Nothing is there to understand here. Ohm's law, the Ohm is a scientist. Ohm is a scientist. So he just he derived this formula. V is equal to I into R. Yes.
Discovered or
So you have max class at 6:50.
Yes, ma'am. 2 classes.
yes, ma'am.
Okay, fine. Yeah, I know that we will complete, no problem, Sharvik. So one more thing, maybe we will do the problems tomorrow then. I'll leave you soon. So this is series and this is parallel. So how the voltage will work in series? So V is equal to V1 plus V2 plus V3. If I have lot, like one voltage is there, 3 resistance is there. So V will be basically V1, V2, V3. So V1 will be present in R1, V2 will be present in R2, V3 will be present in R3. Yes.
Ma'am, simply like I like Okay, ma'am, you can continue. I just forgot.
Okay, so in parallel connection,
that formula again of Ohms.
Yeah.
Thank you. I'm done.
V is equal to I into R. V is volts, currents, and resistance. Yes. Yeah. So series. So in series, this looks like this. In series, voltage will be different from here to here, and from here to here, and from here to here. So there will be 3 different voltage in series connection. Voltage will be different. It will be different. So basically, if you want to have total voltage, if you want to find total voltage, you have to add the voltage of in every single point. Near R1, near R2, near R3. You have to add them all. Then only you will get total voltage. But when it comes to parallel, there is only one voltage. So there will be no voltage difference here. There will be no voltage difference in because the current is dividing equally. There will be no voltage difference.
And so, if the voltage is given as 5 units, so the
It will
total
be constant.
voltage will be like 5 only.
5.
Constant.
Yeah, 5 only. Yes. But when it comes here, in question itself, they will mention you like when it voltage near R1 is 5, voltage near R2 is 2, like that they will mention. But when it comes to parallel, it is understood that no voltage will not change. Yes. Coming to current, please note it very, very carefully. In series, there will be no change in current. Current will be same throughout the, but in parallel, current will not be same. Current here will be different, current here will be different, current here will be different. Yes? Yes?
Yes, ma'am.
Coming to resistance. In resistance, when you want to calculate the resistance of series connection, of any series connection, you just
Ma'am, the
simply
same you
them.
will do like velocity. Means add on.
Yes, not velocity, voltage.
Yeah. Yeah. Sorry.
Yeah. When it comes to parallel, you have to reciprocate it 1 by, you have to make it 1 by R. The resistance will be inverse there. Yes. You can ask me why, ma'am, these many confusions here one, because scientists have did technical experiments under laboratory. They have noticed that the current is not same in parallel, but current is same in series, but voltage is like they have like measured it, how it works. They have analyzed it and they have derived these formulas. Yes. So we cannot question them why it is so, because they have under laboratory condition, they have made the experiments and they have given us all these things. Yes. Why I'm giving all these things? Because we are going to solve the problem. While solving the problem, you will get confusion. So when it is series, when it is parallel, where to use which formula? If I'm asking you to find the total voltage in series, then the formula is different. V1 is equal to like V1 plus V2 plus V3. So when it comes to parallel, it is no need of calculating any voltage. Only one voltage will be there. Right?
Ma'am, can you share this PPT in the Rise app so that we can practice?
Sure. Yes. And then features. So I'll share after next class. Okay, you're having your Sunday test. Okay, I'll share, no problem. I won't ask any question from this because I have some questions. So we can't. So this question is actually higher order. We will be solving in the class this question. So, but just we will complete this and I leave you because you have max class also. So
Ma'am,
features.
Ma'am,
Yeah,
could I take screenshot of that slide?
you can take those things, no problem. I will share the PPT, no problem. I'll share because you have test, right? So I'll share. So test portions basically till last class. Yes. From first class till last class. Yes.
Ma'am, the
don't-
features, like the
Yeah.
features of the series is like if one of the component burns, then is it like the current will become active or it will be inactive?
No, the thing is what in features, what they're trying to say, the advantage of series and like advantage and disadvantage of series. So I'm asking you one question. In real lifetime, there is no switch here. There is no switch here. In real life, what they will happen, what they will do, no, they'll put a switch here. They'll put a switch here. So maybe the resistance is there. For example, there is a bulb also there. Remember, there is a bulb here. There is a bulb here. Okay. So what happens when the current is coming from here? The current is flowing from here. Current is entering into this circuit. And this circuit is getting, like, I want to switch on only this bulb. These two bulbs I don't want to switch on. So that case, will have a switch here. So the current will pass through this circuit only. These circuits, like these circuits will not have, I mean, this circuit only will not have the current.
Ma'am, should we keep like one battery so only one bulb lights up and the others don't?
Yeah,
Ma'am,
actually, I'm
like-
telling the application.
Ma'am, you're trying to say like if one in a series, there's one disadvantage that if one burns, then the total will not work, and in the parallel,
Totally
if
will
one,
burn, yes.
yeah, ma'am, and if in parallel, if one component burns, then only that part will stop
That part
working,
will
and the
burn.
rest all will start
Yeah.
working.
Yeah, if this part is only burnt, so these two bulbs, so for example, the bulbs are connected. These two, for example, this is room 1, this is room 2, this is room 3. Okay. So in the room 1, some problem is there. Room 1 circuit will only burn and it will only get destroyed. But room 2 and room 3 current will be coming. Because this is basically parallel connection, no? So parallel connection, the circuit, the current will be going on to this and this. Here only some problem is there. Only here, this part of the circuit will only be, we want to remove or change or something, repair work should be done. But when it comes to series, it's not like that, right? When one bulb, so for example, 3 bulbs are there. This bulb, like there is a small circuit problem in this area. Okay, so that all the bulbs will not work. This bulb also won't work, this also won't work, this also won't work. Yes, and if there is an excessive current, full circuit will burn off. All the bulbs will burst. But in the parallel, when there is an excessive current, only this resistor will go. Like only this full circuit of that resistor will go then also. But all others will not get affected. Because they all have separate resistors, right?
Yes, ma'am.
Understood something?
Ma'am,
Not clear?
yes, ma'am.
Very, the concepts are so much, or I am burdening you, something like that happening?
No, ma'am, it's just like
No.
there's so much, like
We are
because
learning so
compared to-
much.
No, like compared to 6th grade, it's like so much new.
It is so much actually. I'm teaching you 8th standard portion, to be frank. This is not 7th standard. Actually, in 7th standard, if I am following your NCERT book, I would have started heating effect 3 days back. Whatever we are learning, I'll tell you after this slide. After this slide, not all this slide also. Even this is an extra for you. And this one is an extra. And this is an extra. So basically your NCERT book had electricity, electric charge, what is electric charge, what is electricity, and what is battery, simple definition of battery, and they have given the definitions of everything, and they have given this activity 1, this activity I shown you, and they have given this activity 2, and some more activities are there. That's all actually. So after that, whatever we are discussing, it's all 8th standard level, but it is necessary. It is necessary because you need to learn, you need to always be, I had told you, right, everybody, you need to always be one step ahead than everyone. You need to always be one step ahead than everyone. When you go to 8th standard, when your teacher teaches these things, you should be already aware. Just one glance you have to have and just go solve the problems. That's it. So whatever we are learning is nothing. Problem solving is the main problem here, actually. You know, we learned everything. We just seeing series and parallel connection. Everything seems to be very okay. But when it comes to the sums, see sum.
Even IQ by T is 8th grade level.
Yeah, IQ, that itself we have struggled somewhat. So when it comes to problem solving, the real game starts. So be ready for that. I'll give you more problems. Don't have to worry. This all will help you for competitive exams at the end. That's it. Yes.
Okay.
We can stop here. You have maths class. You have, maybe you will be having some homework.
I'm
to do.
like,
Yeah.
if I have some doubts in what in this chapter, in another chapter, can I ask you personally?
Yeah, you can, surely. I already said you can ask me.
Okay.
Don't disturb your parents. You know, they have a lot of works. They are leaving you people to us because they believe us. So you don't have to disturb them. Okay. Yeah. Okay. Bye, everybody. I'll give you homework in the group. Okay. Bye. Bye.
Thank you, ma'am. Bye, ma'am.
Bye, ma'am. Thank you.
Bye, ma'am. Thank you, ma'am.
Bye.
Bye.